Hi everyone, welcome back to this channel. This quick video, I'm going to share with you some of the questions that I've been asked on how to verify whether the tester is ready for testing. A lot of times we have the tester and then we run a calibrations and then what's next. So it's a bit of a different format today, and in this short sharing, I'm going to share with you my experience as a manufacturing engineer. How do you verify our tester readiness before you run the manufacturing test? So the first question is, what is test? There are two ways of explaining it. If you're from management, you might say that it's the art of proving your product wrong before your customer do. So you want to make sure that your product fail in your manufacturing floor instead of after you sell it to the customer. And from the engineering standpoint, it's a systematic process of applying control inputs to the product or system, measuring the outputs and evaluating conformance to a specified requirements. Means that you run the test, you get the measurements, you get the result, and then you compare to the limit or specifications. If it's fit your limit or specification, then the product pass. So how do I know my tester is ready? It's a questions. How do I know? I run the calibrations, but how do I know the calibration is done correctly? These are the few things that we normally make sure before we run the test, like the tester setup. Sometimes we have to run a self-test on some of the instruments and making sure that it's still working fine. Then calibrations, especially when you have testers such as a network analyzer or even the spectrum analyzer, just to make sure that the offset is done correctly. Amplifier, filter, you use the right thing, you use the right product in the whole network of tests. And then you also make sure that the environment is constant, where your temperature is controlled to a certain degree, your humidity is controlled to a certain degree. The question is, I've done all these things. How do I know whether my station is ready to run the test? So one of the concepts that I've learned over the years is what we call a golden unit or a reference unit. Depends on your preference. So I'll call it golden unit. So it's a reference device that you verify a document, its performance, and use to validate the accuracy and stability of the test system. After the calibrations, you use this unit and test it and see whether when it's supposed to pass, it passes. When it's supposed to fail, does it fail? So that's a professional definition. And this is what I will put it as a layman term. So the one device that always behaves even when everything else doesn't. So it's a factory favorite child, never complains, always pass and keep the test station honest. It's the last gatekeeper before we release the tester to the wall. So how is it being used? So we have a tester and then we test our device under test. It can be a circuitry board, it can be an antenna, it can be a filter. So if the golden unit pass, fine. If the golden unit fail when it's supposed to fail, it's fine. But what if we have a not so sure situation? So as you can see also in the test result, normally we have pass, fail, or question mark, borderline, margin, fail. These are the situations that you will encounter in the production floor. So other consideration when we use a golden unit. So when you use a golden unit, it's an easy way to determine the tester readiness. If it's supposed to pass, it passes. Supposed to fail, it's supposed to fail. The question here is, I'm only using one golden unit. Is it comprehensive enough to cover all test conditions? Like if my unit is only giving a pass result, does it cover the fail portion? So these are the questions that you have to ask yourself or your team. So when it fails, does it fail at the right parameter? You might have a fail unit that fail at parameter 2. But when you run the test to verify your tester readiness, it might fail at parameter 7. What does that tell you? Is that a good unit? Is it a good check for readiness? So these are the things that you have to have it in your checklist. There's a term that we use choosing the golden unit is what we call a sanity check. So we want to have a set of pass unit. This set of pass unit is supposed to pass the specification or the limits that we set. And the fail unit is supposed to have fail. Then we have, if you are allowed in terms of cost and process, you can create some borderline units. Some might have parameters that are quite close to borderline. You want to make sure that it still gives you the same reading just to verify your tester readiness. So how many units are considered enough to be effective? There are many ways to determine that, and it's all drawn down back to the cost. There's no one size fits all number. From my experience, it depends on your test complexity. For 10 parameters, probably you have lower numbers of golden unit. For 100 parameters tests, you might want to increase the number of golden unit because you want to cover all possible failure on each parameter. Then the cost for each golden unit. Electronic manufacturing is those PCB board, which cost probably less than $1. But there are some manufacturings that manufacture instruments, for example, which cost a few $1,000s. You can't afford to have, let's say, a $3,000 per piece golden unit lying on the test floor just for you to verify. You might limit it to 1 unit. It all boils back down to the cost, and then the test time. I'm going to cover more on that in the next slide. So for example, in the ideal world, I have choose 5 pass unit, 5 fail unit, 5 borderline units. And let's say each test time is about 2 minutes for 22 parameters, and loading time is where I change from one unit to another. It takes about a minute. It's a bit slow, but just for example. Then calibrations, let's say before we test it, takes about 5 minutes per shift. So estimated time for tester verification, let's look at it. It's roughly about 50 minutes. Is that the time that you can afford to lose in the beginning of the shift? So these are the questions that you have to ask, and then talk to your quality control engineers or product engineers to lock down on the numbers of unit that you need to verify your tester before you move on. I'm not sure how many of you have heard about this term called GR&R, gauge repeatability and reproducibility. It's a statistical tool to access measurement variation. Even with the variations terms here, there are some consistency in measurement conditions, such as your setup, the cable that you use from the instruments to your device on the test, the instruments that you use on the rack, the cables, the connections, the environment, the room temperature and humidity, the use of golden unit. It's a control process that is mentioned in GR&R process. In detail, you can actually go to this reference. I'll put this in the comment section so you can just click and look. It's a very detailed explanation from these two websites, which I kind of like it. I won't cover that here. Yeah, just spend some time reading through, and then you can see how you can generate out the golden unit based on the process that is mentioned here. So basically, you want a group of operators that will run the tester to try out when you try to generate the pass, fail, the borderline golden unit. So you predetermine, let's say, 15 units, 5 each on each category, and then you get a group of operators over a span of few days. Every day will be morning, afternoon, and late in the shift, and then you make sure that all of them have a good combinations of variations, and then you get the average of the reading, and then you see whether the pass will still maintain pass, and then the fail will fail. The borderline will give you a borderline reading. So with all these informations combined, and then of course you can use an Excel file to gauge the readiness of your tester by checking each parameter, and then from there you can have a calculated risk on the readiness of your tester before you release it to the productions. So again, this is from my experience. Things might have changed over the span of 20 years. You probably can ask around, like the AI machine, the ChatGPT or Copilot will tell you more about all this process. So the next question is, do we need to have a new batch of golden unit? The answer is yes, especially when you have changes made in the manufacturing process, such as you use a new wafer, or the device on the test is using a new test flow, or different material, change in design, change in test requirement. So these are the things that you have to reconsider. So you have to treat it like a new product where you have to regenerate a new golden unit to use to verify the readiness of your tester. So as a summary, we want to make sure that our tester is ready before you run the manufacturing test. If the tester, let's say, is not ready, it might be over reject your unit and then makes your yield very bad, or under reject the unit, and then that will cause more problem because you think that the unit is ready, tested, it passed when it's not supposed to, and then it's sold to customer, then you have to recall. So these are the risks that involve when your tester is not ready but you release it to the manufacturing process. So you can use golden unit as a reference for calibrations and verifications. So after calibrations, use a golden unit to verify that your tester is ready. Check every parameter. It might deviate by a certain amount, like let's say today when you measure the S21 for this device and the test is minus 18, but tomorrow you get 17.9. That's the 0.1 dB makes it into your specification, your tolerance. So these are the things that you have to predetermine how much is too much. Then you apply the statistical analysis based on GR&R process to confirm the measurements reliability and also your tester readiness. You can apply this golden unit concept to the process. You can always check with the AI machine on what is the latest practice. I hope this helped. If you have any comments, just leave it in the comment section. Thanks for your time.